Picking up from the cell detect example, we're going to use the wavdetect tool in a similar way. It takes a little bit longer to run, so I'm going to go ahead and get it started here. So with the wavdetect, uses a HAR or Mexican hat wavelet, sombrero wavelet. It does a much better job in crowded fields of separating close sources. Now, kind of interestingly enough, we can actually run multiple tools, so I could actually run a second source detect. I can run the get source region task while the wavdetect task is running. And you see that, which all in all isn't too useful. So what good source region does is it just identifies groups of pixels that are above a background threshold that it determines. So you saw it pretty much detected every pixel. It doesn't group the pixels into sources, it just says these pixels are above threshold. Another way to say it is the pixels that aren't above threshold are the background, so that's kind of its real use as a background determination. And it is now finished. So you can see, same thing like cell detect, we've output source detect regions. More or less these regions represent a 3 sigma kind of measure of the extent of the size. It's not the ellipse represents the size of the source on the sky. It doesn't represent position errors. And you can see it. I could zoom out a little bit. So that's wavdetect.